Hello everyone. Welcome to this video on Ethernet technology. In this video, we will explore the standards, frame format, and collision detection mechanisms that make Ethernet the dominant local area network technology. So, what exactly is Ethernet? Ethernet is a network technology primarily used for local area networks, or LANs. It was developed in the 1970s at Xerox PARC, which is short for Palo Alto Research Center, and later standardized as IEEE 802.3. Ethernet uses a protocol called Carrier Sense Multiple Access with Collision Detection, often abbreviated as CSMA/CD. Some of the key characteristics of Ethernet include shared medium communication, support for various physical media like twisted pair cables and fiber optic cables, and a speed evolution from 10 megabits per second to 400 gigabits per second. Due to its flexibility and scalability, Ethernet has become the foundation of most modern LANs. Let's take a closer look at the evolution of Ethernet standards. As you can see in the table, the standards have evolved significantly over the years, increasing both speed and capabilities. Let's start with the 10BASE-T standard, which was introduced in the year 1990. It operates at a speed of 10 megabits per second, uses twisted pair cables as its media type, and has a maximum distance of 100 meters. Next, we have the 100BASE-TX, which came out in 1995. It supports a speed of 100 megabits per second, uses Category 5 UTP cables, and also has a maximum distance of 100 meters. Then there's the 1000BASE-T, introduced in 1999, which operates at 1 gigabits per second using Category 5E or Category 6 cables, again with a maximum distance of 100 meters. The 10GBASE-T standard, released in 2006, bumps the speed up to 10 gigabits per second and uses Category 6A or Category 7 cables, maintaining the 100-meter distance. The 40GBASE-T standard, introduced in 2014, increases the speed to 40 gigabits per second and uses either Category 8 cables or fiber optic cables, with a maximum distance ranging from 30 to 100 meters. Finally, we have the 100GBASE-T standard, released in 2016, which supports 100 gigabits per second and uses Category 8 cables or fiber, similar to the 40GBASE-T, with a distance of 30 to 100 meters. Each of these standards represents a significant advancement in Ethernet technology. Now let's discuss the Ethernet frame format. An Ethernet frame is the basic unit of data transmission in an Ethernet network. It consists of several fields, each serving a specific purpose. Let's start with the preamble, which is 7 bytes long and is used for synchronization between the sending and receiving devices. Following the preamble is the start frame delimiter, or SFD, which is 1 byte long and indicates the start of the frame. Next, we have the destination address, which is 6 bytes long and specifies the media access control or MAC address of the receiving device. Then comes the source address, also 6 bytes long, which specifies the MAC address of the sending device. The length field is 2 bytes long and indicates the length of the data in the frame. The data field contains the actual payload, ranging from 46 to 1,500 bytes. Lastly, the frame check sequence, or FCS, is 4 bytes long and is used for error detection via cyclic redundancy check. Now let's discuss the frame sizes. The minimum Ethernet frame size is 64 bytes, while the maximum is 1,518 bytes. Jumbo frames, which are larger, can support up to 9,000 bytes. The key components includes media access control addresses, which identify devices, the frame check sequence, which detects transmission errors, and the preamble that ensures synchronization. Now let's delve into media access control, or MAC addressing in Ethernet. A MAC address is a 48-bit, or 6-byte, unique identifier assigned to network interfaces. It is typically represented in hexadecimal format. As you can see, it is shown here as 00:1A:2B:3C:4D:5E. MAC addresses include unicast, which is for an individual device, broadcast, which is for all devices on the network, and multicast, which is for a group of devices. MAC addresses consists of two parts. The first 3 bytes, which are the organizationally unique identifier, or OUI, and the last 3 bytes, which is the network interface controller specific identifier. MAC addresses are burned into the hardware by the manufacturer. If you want to check if a media access control address is a broadcast address, you can compare it to the broadcast MAC address, which consists of all Fs as shown in the code. For multicast MAC addresses, the first byte starts with 01. Now let's explore carrier sense multiple access with collision detection, or CSMA/CD. This protocol is used in Ethernet networks to manage how devices share the network medium and handle collisions. Here's how it works. First, the carrier sense process is used by a device to listen before transmitting. The device checks if the network is idle before sending data. Next, we have the multiple access process, which means all stations have equal access to the network. If the network is idle, any device can transmit data. When a collision occurs, simultaneous transmissions can be detected. If 2 or more devices transmit at the same time, a collision occurs. This collision is detected by the transmitting devices. After a collision is detected, a jam signal is sent to notify all stations of the collision. This signal informs all devices on the network that a collision has occurred, so they stop transmitting. Then, each device initiates a backoff process. Devices wait for a random amount of time before attempting to retransmit data. This random backoff helps to avoid repeated collisions. Next, we will explore the binary exponential backoff algorithm. The backoff time is calculated using the formula backoff time equals R times 512-bit times, where R is a random integer between 0 and 2 to the power of k minus 1. In this equation, k is the minimum of n in 10, where n equals collision attempts. After the first collision, the device waits 0 or 1 slot times, which is determined randomly. After the second collision, the device waits 0, 1, 2, or 3 slot times, again chosen randomly. After the third collision, the device waits between 0 and 7 slot times, again randomly. The maximum backoff window is 1023 slot times, which occurs after 10 or more collisions. For example, if you have a 10 megabits per second Ethernet, 1 slot time, which is 512-bit times, equals 51.2 microseconds. The advantages of this algorithm includes it reduces the probability of repeated collisions, it provides fair access to the medium, it adapts to network congestion levels, and after 16 failed attempts, the transmission is abandoned. Next, we will explore modern Ethernet developments, including switch-based Ethernet. Switch-based Ethernet replaces shared medium with dedicated connections. This eliminates collisions in full duplex mode. Switches forward frames based on media access control, or MAC address tables. This allows for simultaneous transmissions and supports microsegmentation of networks. Here's a comparison between hub-based and switch-based Ethernet. For the collision domain, hub-based Ethernet is shared, while switch-based is per port. For bandwidth, hub-based Ethernet is shared, while switch-based is dedicated. Carrier sense multiple access with collision detection, or CSMA/CD, is required for hub-based, but not needed for switch-based. Some advanced Ethernet features includes auto-negotiation of speed and duplex, power over Ethernet, virtual LANs, quality of service, and link aggregation. Some Ethernet applications in data centers includes high-speed connections such as 40, 100, and 400 gigabits per second, low-latency switching, converged enhanced Ethernet, and data center bridging. In summary, Ethernet is the dominant local area network technology, standardized as IEEE 802.3. The Ethernet frame format includes a preamble, addresses, data, and a frame check sequence. Media access control, or MAC addresses, uniquely identify network interfaces. Carrier sense multiple access with collision detection, or CSMA/CD, resolves collisions in shared media environments. The binary exponential backoff algorithm manages retransmissions. Modern Ethernet uses switches to eliminate collisions. If you want to learn more, here are some further learning resources. You can refer to the IEEE 802.3 standards documentation or use Wireshark for Ethernet frame analysis. You can also review Ethernet technology evolution case studies or use network simulation tools like Packet Tracer or GNS3. Thank you for watching. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.